In this lecture, we shall do some problems on pressure. We shall start with simple problems illustrating the definition of pressure and go towards more challenging problems step by step. Our first problem is this one. Problem 1 is telling a woman of mass 60 kg has height 1.6 meters and shoulder width 45 centimeters. She wears shoes of length 25 centimeters and average breadth 7 centimeters. Approximating the relevant areas as rectangles, calculate the average pressure she exerts on the ground when standing, on the bed when lying flat. In part C, what pressure does the woman exert if she stands on stiletto heels of total area 2 centimeters square? A funny question that requires some imaginative approximation. So let us first write down the different informations given. First, the mass of the woman, M is equal to 60 kg. Height of the woman, H is equal to 1.6 meters. Her shoulder width, small w, is equal to 45 centimeters. That is 0.45 meter. We shall convert all the units into SI to avoid any future silly error. And as for either shoe she is wearing, that is for each of the two shoes, the length L is equal to 25 centimeters, that is 0.25 meters, and the average breadth, let the symbol be small b, 7 centimeters, that is 0.07 meter. We shall also need later in part C of the question that the total area of the stiletto heels on which she might stand, that area is given to be 2 centimeters square, which is 2 into 10 to the power minus 4 meters square. With this information, let us move on to the part A of the question, and we find out here the average pressure given by her on the ground when standing. Now, first of all, we know the definition of pressure. The average pressure is the normal force acting on a surface divided by the area of that surface. So, in this case, as the woman is standing on a horizontal ground, there is a force of gravity acting on her exerted by the earth mg downwards, and the equilibrium of this person requires that there must be a normal force applied by the ground in the upward direction, which must balance this force of gravity. Therefore, the normal force given by the ground on the woman is equal in magnitude to the force of gravity mg. And then, by Newton's third law, if the ground has given an upward force of N onto this woman, the woman also has given an equal but opposite force, that is minus N, onto the ground in the downward direction. And we are looking for this minus N, that is the normal force given by the woman onto the ground here through her shoes. So you see that this force N has the magnitude equal to the force of gravity acting on this woman's body. We understand this, and therefore the pressure exerted by her on the ground in standing position is the normal force N divided by the total area of the two shoes, that is twice the area of each shoe. And since we are given that the shoe has got length and breadth given by this data, and we can approximate relevant area to be a rectangle, therefore we are getting the area of each shoe to be the product L into B. Now this, of course, I can write this N thing as the force of gravity in magnitude, of course, acting on the woman, and putting the values. M is 60 kg, the value of G is 9.8 meter per second square, divided by twice the length of either shoe is 0.25 meters and the breadth is 0.07 meter. Complete the calculation and show that the average pressure exerted by the woman on the ground while standing is coming out to be 1.68 into 10 to the power 4 Newton per meter square. You can call alternatively as Pascal. Newton per meter square is also known as Pascal. So this is the answer of the first part of the question. Moving on to the part B of the question, they are asking what is the pressure exerted by her on the bed while lying flat. And in a bed, as she is lying flat, well, I'm drawing just a basic figure to understand, we can approximate the area of our body in contact with the bed to be a rectangle of dimensions, this height into shoulder width. And once again, you can argue that the gravity force acting on the woman's body must be balanced by the normal force given by the bed. As an action-reaction, the woman also exerts a downward force that we called earlier minus n, and this n is equal to the force of gravity only. So whether she is standing on the ground on her shoes or she is lying flat on the bed, the normal force given by her on the surface in contact remains the same n equal to the force of gravity acting on her.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.